Hi, this is Hafiz Rafraz, and today we are going to solve A-level physics paper. As you can see on your screen, this is a physics paper, and we will solve question number 12 of this paper. First, let me show you the question. The question is about conservation of momentum, which is a very basic principle of the mechanics. And this question, in this question, you can see this question has two parts: A part and B part. In B part, we have two spheres. One is aluminium sphere and second is steel sphere. These two spheres collide with each other, and after collision they may move in opposite direction or they may move in same direction. It will depend on after calculation. But before moving on to the part B, first we will solve the part A of this question. This question of part A of this question says that the principle of conservation of momentum mean we are to state the law of conservation of momentum or principle of conservation of momentum. So first let me write the principle of conservation of linear momentum at here. The, this law states that the total linear momentum of an isolated system remains constant. This is our question principle of conservation of momentum. This law states that the total linear momentum mean we have total linear momentum mean we have one body or two body or three body, and all these are colliding with each other. Then after collision or before collision, their total momentum will remain constant. This is the statement of principle of conservation of linear momentum, or it can be written in another way. So I am writing it in another way. Let me write it here. And this is the second statement, or we can write the first statement in simple ways. And this says that momentum before collision is equal to the momentum after collision. Now let me explain that we have two or three bodies, and when these bodies collide with each other, but before colliding with each other, they have a momentum, and we will collect all these momentums before collision. But after these body collide with each other, and after collision, their velocity change, their mass remains same, but their velocity change. So their total momentum after collision also change. So this law states that the total momentum before collision and after collision remains same, or in other words, the total momentum of a total linear momentum of an isolated system remains constant. So let me write the mathematical equation for this principle. So I can write m1 v1, mean m1 is the mass of first body, v1 is the velocity of first body, plus m2 v2 plus m3 v3 up to so on, and it will be constant. This is the principle of linear momentum, or it can be written in simple way that If we have only two bodies, then first bodies have momentum m1 v1 and second body have momentum m2 v2. At this momentum is before collision, and after collision their velocity change. So the velocity of first body becomes v1 dash and the velocity of second body becomes v2 dash. So the momentum of first body after collision becomes m1 v1 dash and momentum of second body after collision become m2 v2 dash. So this statement, this formula or this identity is about the second statement, and this formula or identity is about the first statement. This was all about the law of conservation of linear momentum. Now I will move to the question part B of this question, and I will solve the numerical. And this numerical is some of this numerical is written above here. An aluminium sphere collides head on with a stationary steel sphere. Mean we have two spheres, and one is aluminium sphere which is moving on, and second sphere is steel sphere, and steel sphere is is stationary. As you can see here, the first sphere, aluminium sphere, is moving with velocity 10 meter per second, and it has the weight 2.7 kg. Second sphere, steel sphere, has velocity 0, mean it is at rest, and it has mass 7.9 kg. So I will use the second statement or second formula which I wrote above, that is m1 v1 plus m2 v2 is equal to m1 v1 dash plus m2 v2 dash. I will use this formula or expression to solve this numerical. So first I will calculate m1 v1. This is m1 our, this is m1, and this is v1. So m1 v1 will become equal to, I will multiply 2.7 with 10, and this will become 27. This is m1 v1. Now I will calculate m2 v2. This is m2 and v2 is 0 because it is stationary. So m2 v2 mean 7.9 cross 0, and it will become 0. So similarly, I will calculate m1 v1 dash and m2 v2 dash, and this is about after collision. This you can say after collision. After collision, sorry, I can write, because here the velocity shown is only v. So at the place of v1 dash, I can only write v. So this will become m1 v, and its momentum will become m2 v dash. I'll write it as v dash. So this will become 2.7 cross v, and this will the momentum of first aluminium sphere after collision, and then I will calculate the momentum of second sphere which is steel sphere, which has the having mass 7.9 cross 5, and 7.9 cross 5 have the answer 39.5. So let me go down so that I so here again I will write the formula and I will calculate the momentum. So my formula was that m1 v1 plus m2 v2 is equal to m1 v plus m2 v dash. So m1 v as calculated here is 27, so it become 27 plus m2 v2 is calculated here. So where is m2 v2? This is because v2 velocity is 0, so m2 v2 is 0, so 0 is equal to m1 v dash, m1 v dash, and this was m1 v dash, this was 2.7 v, this was 2.7 v plus m2 v2 dash, and this was calculated as m2 v2 dash, and this is 39.5. So we want the value of this v dash, so this 39.5 will be subtracted from this 27, so I can write 2.7 v dash equal to 27 minus 39.5, and this will become minus 12.5 will be equal to minus 2.7 v dash. We need only v dash, so we will divide 12.5 by 2.7, and answer will be minus 9.8. This minus sign here in the answer, this minus sign shows that the aluminium ball will be moving in the opposite direction of to the steel ball. Minus sign shows that the steel ball will be moving in opposite direction to that of the steel ball. So let me go again on to the question so that I can repeat it. Here I have two balls, which is one ball is aluminium ball, and second one is steel ball. Aluminium ball is at rest. Aluminium ball is moving with velocity 10 meter per second, having mass 2.7 kg, and steel ball is at rest, having mass 7.9 kilograms. So first this is our expression which we will use. So this is the velocity v1 velocity, this is the v1 velocity, and this is the v1 mass m1. So first I calculated m1 v1 because in this expression we have m1 v1 plus m2 v2. I calculated m1 v1. This m1 v1 is equal to 2.7 cross, let me wait, this here I calculated this is here I calculated m1 v1, and this m1 v1 is equal to 2.7 cross 10, and this becomes 27. Again I calculated m2 v2, and this becomes 7.9 cross 0, and it becomes 0. So the total momentum before collision is written at here, m1 v1 plus m2 v2 mean 27. This 27 plus 0, it becomes 27 plus 0, 27, and momentum after collision is m1 v1 dash and m2 v. So we can say not specifically that v1, we can say only v, because in the question he wrote v, so we can write m1 v dash plus m2 v dash as I wrote in here. So m1 v dash mean momentum after collision. Momentum after collision, the moment mass is same again, 2.7 kg, and the velocity after collision is not known for the aluminum sphere, so I wrote 2.7 into v dash. Now the momentum after collision for second steel ball, this is I calculated it here, m2 v2 m2 v dash, and the mass of the steel sphere is 7.9 kg, 7.9 kg, and moving with velocity 5 meter per second. So I multiplied 7.9 cross 5 meter, and answer is 39.5 meter. So I at the place of m2 v dash I wrote 39.5. 27 plus 0 on the left side, 27 plus 0 becomes 27, and on the right side 39.5 is being added. So to find the value of this v, I will subtract this 39.5 from 27. So I here 27 minus 39.5 is being subtracted, and answer becomes minus 12.5. Here as I am again writing it, answer become minus 12.5. We need only velocity of aluminium sphere, and this is v dash or only v, so we can divide 2.7 because 2.7 is being multiplied with v dash, so we will divide 12.5 with this 2.7. When we divided 12.5 with 2.7, and answer become minus 9.8. Minus sign shows that the aluminium steel ball is, if the steel ball is moving in this direction, then aluminium ball will be moving in opposite direction. So it means that before before collision, steel ball was at rest and aluminium ball was moving in this direction. But after collision, steel ball is moving in this direction and aluminium ball is moving in opposite direction. Many sign, negative sign or minus sign shows that the velocity is opposite. So this was our all the question about law of conservation of momentum, and we also calculated the velocity of aluminium sphere. Thank you for today.